All right. Since we had some finagling issues last time, we're going to continue. We're going to briefly go through operators again, and we're going to finish operators, talk about all the arithmetic operators, and then we're going to talk about variables. We have about an hour on this content, and then we're going to spend the next 30 to 45 minutes talking about variables. So we're going to go over today. I will pause at 9 o'clock. You guys can leave if you want, but I'm going to keep going here because we're a little short on time. We got a bit of a late start.
Are you going to record the rest through that 9:45 if we have to leave right at 9?
Yes, I did start the recording, and then we're gonna continue at that pace. Okay, so what are operators in Python? So operators are special key symbols or keywords used to perform operations on variables and values. So in Python, there are certain things that the language reserves as these things called keywords. And that means that it means the same thing to me as it means to you in your program, as it means to somebody else in their program. So I can't change what a plus sign does. A plus sign has a very particular function and role within Python, and that's what a keyword is. A keyword is reserved and has a particular function, and you can't overwrite or change it. These are not the only keywords. There's a lot of keywords in Python, but we're going to talk about these operators. These are some of the operators that exist in Python. So we're going to start to understand what you can do with a programming language. The first assignment that you guys have is you're going to build a calculator. So assignment 1 is a calculator. That's why we're talking about operators. And then we're going to talk about what operators operate on, which are variables. So here we have arithmetic operators, relational operators, logical operators, and assignment operators. So what are arithmetic operators? Our arithmetic operators, they're going to perform basic mathematical functions. So we can do addition, 3 plus 2. We can do subtraction. We can do multiplication. So if we have, oh, actually I'm a slide ahead of myself on that. I'm going to do slides, and then we're also going to do I'm going to code some of these in notebooks. Sorry. So we have 3 plus 2, 3 minus 2. These are all the things that you might expect and might expect something like a programming language for which you could create a calculator to have functionality to do. When you're using an operator, operators perform on 2 objects. So we have to go object, operator, object. So 10, the operator is the plus sign, 3. We can't do 10 plus. If we did 10 plus, that would probably throw an error. Should we try that? Should we see what error we get? If we did 10 plus, we're probably going to get an error. It's grabbing compute, so it'll take just a second here. It says, oh, invalid syntax. So we got a syntax error, which means that the language doesn't know what to do with that. If we did plus 10, would we get an error? Nope, we didn't get an error. So I guess plus 10 did not give us an error. Let's plus 10, 13. That's going to give us a syntax error because we went operator, object, object. So we have to go object, operator, object. Spaces are ignored, so we can do 10 plus 3 and no space between them. Or we could do 10 and lots of spaces, plus sign, and a 3, and we would get the same answer. So we get 13 and we get 13. Objects can be stored, so let's look at that. So I think I have that in here. So we can do 10 plus 3, and we get 13. We can do 10 plus 3 with no space. We can do lots of spaces here if we want. 10, lots of spaces plus, maybe a few spaces. I don't know why I put a period there, sorry. And it's going to give us the same thing. So that doesn't matter. Those spaces are ignored by our Python interpreter. So these objects can be stored, objects can be values stored into variables. So if we create something called a variable, and it's A, and we assign the value of 10 to A, we create a variable called B, and we assign the value of 3 to B, we can do A plus B as well. So over here, we're just adding integers together. We can objects can be value stored in variables as well, so operators can perform on those variables as well. So if we look at this, if we have A, we store 10 into A, we store 3 into B. We're still going object here as A, operator as this plus sign. Sorry, I'm trying to highlight the plus sign. And object as B. So object, operator, object. Another thing to note about operators is that the results of this operation can be stored into another variable. So C equals A plus B.
So does the equal sign count as an operator?
That is a great question. The equal sign is an operator. The equal sign is a assignment operator. No, it's a really good question. Some of these things, it's like, which one do we talk about first as we start to build some of these foundational concepts? I think today you guys will feel very grounded by the end of this. Some stuff that we can work from. So yes, that is the assignment operator. So C, assignment operator, object A plus our what did we call these? Sorry. Our arithmetic operator of the plus sign, and then B. And that'll give us 13. So here's a bunch of coding examples of arithmetic operators. Using arithmetic operators, we can print A plus B, and we'll get an output of 13. We can print A minus B and get 7. We can do A times B and get 30. A divided by B, get 3.333 repeating. A modulus B, get 1. A to the power of B, get 1,000. And A floor division B and get 3. I think we have this in our notebook, so let's look. So here, by the way, our A plus B we said was 13. We can take this A plus B, which evaluates to 13, and store that value into C. And C we output as 13. Here's all our examples of arithmetic operators. All of these notebooks, by the way, are in the Google Drive. So you should be able to see these notebooks inside the Google Drive. And you guys can you can download these, move them to your own Google Drive location. You can play with them, you can run them. I would highly encourage that you guys actually try to play with the code and run the code. If you're like, what would happen as we do this? That's really the only way that you learn programming is getting hands-on. So you'll see as we go through these, I have you try it. So what I want you guys to do is open up a Google Colab notebook, and I want you to try this. I want you to try to add 25 and 7. I want you to try to multiply 12 by 13, divide 100 by 6 and show the results as a whole number, which is floor division, so perform floor division. Find the remainder when 29 is divided by 5, and calculate 4 to the power of 3. So open up a notebook. Let's spend, this is really the only way that you learn programming is actually just trying stuff. So go ahead, open a notebook.
So is the file in Google Drive?
You can make a new file. You can use the file that I have in the Google Drive. You guys can do it either way that you want. You can do the You Try It exercises in any IPython notebook that you would prefer.
So how do we get to the Google Drive? I can only open the sheet, but not the actual drive.
Not the actual drive. Let's see. Okay, gotcha. You need access. Let's do. I am just going to share.
I don't have those files in my Google Drive. She has not shared it.
It is. It is shared. Oh, is this from fall? Oh, that's fall. I'm realizing I should not do this on the recording. One moment. I forgot we were recording. Showed people's email addresses. No, student folder. I'm just going to change it to anyone with the link because we seem to be struggling with this access here. So here you are. I put the Google Drive link in the Slack channel. Are you guys able to access that?
Oh, there we go. Okay.
So if you would like to, you can download from there, move it to your own working location. Please do not edit the files that are inside of the class folder because I use those for everybody. Okay, so where were we?
I could just say new notebook in Drive and then download it and save it like we did earlier.
Yeah,
to Drive.
absolutely. Yep. Let's spend, so try to do this exercise. Let's spend 5 minutes on this. 8:21.
So we just do this with any notebook?
Yeah, any notebook. So I will do it myself as well. I'm just going to click new. I'm going to click Google Collaboratory. So if you want to make a new notebook, you'll just right click, click more, and click Google Collaboratory. Just makes a new notebook for you. Here we go. So it's called Untitled Zero. I'm going to rename it. I'm going to call it You Try It.
Are you recording?
I am recording. Also, you guys don't have to do it this way. Like you can do it, you can work on in any notebook you want, but this is just how you create a new notebook. So you just right click, more, Google Colab. And it makes a new Google Colab. And then I just renamed it. I called it You Try It. And now I'm going to try to add 25 and 7. So I'm going to do 25 plus 7 and shift enter.
So I can do it for the operator, I know the operator's practice.
Yep.
What we're doing is got more.
This is coding. Yeah. We're coding, guys. We're programming. Okay. Multiply 12 by 3. Did I say 21? Oh, no, we got a few more minutes. Sorry. Getting ahead of myself. Okay. Multiply 12 by 3. How do we do that?
(12/4/3) n. Oh, shit.
12 / 3. That is going to give us an answer. What's that?
Oh, multiply. Yeah.
We do.
Star, yeah, multiply.
Star. Nice. There we go. 12 * 3. 100, divide 100 by 6. How do we do that? You had it before with the /.
Yeah.
There we go. Find the remainder when 29 is divided by 5. How do we do that?
Number equals, we can assign the division. First give the initial answer.
Okay. What's the initial answer?
60.666.
How did you get that?
That was the answer multiplied by 100. 100 times 6. And you divide it with the 16.66.
But if we're trying to find the remainder when 29 is divided by 5, how do we do that?
We type it right here where it's 20.
What do we type?
29 divided by 5.
29 divided by 5. So 29, then what do I hit? What do I do?
To divide is the
Nice. And then 5? Okay. 5.8. How do we get the remainder?
The mod.
There you are. The modulus.
It's the weird. Yeah.
But then
So 5 goes into 29 5 times with a remainder of 4. Perfect. How do we do 4 to the power of 3?
It was not equal star.
Nice. So 4 ** 3.
And then if
64.
we wanted to add star after that 3, I remember that somewhere.
Let's see what it does. Add ** after the 3. So are you saying 4 ** 3 **?
Yeah.
Oops, sorry. **?
Yeah.
Oh, we got an error. Invalid syntax.
Okay.
I wonder what this button does. There we go. Oh, look, it gives us suggestions. That's kind of nice. Let's take it. All right. So for that's a good question. To raise to the power of, the star does go in the middle, not at the end. So it goes 4 star. Remember, it goes object, operator, object. Okay, perfect. Great. We're coding. We're programming. We're moving along, guys. Next, let's talk about another type of operator. So those were our arithmetic operators. Those did math for us. They took two numbers and they applied some math to those two numbers, maybe division, addition, subtraction. We're going to talk about a different type of operator now. We're going to talk about relational operators. And these, it still goes object, operator, object. So it's still a operator. But now we're going to compare two values. And we're going to get a value of either true or false based on that comparison. So we want to know things like, is this number equal to this number? Is this number not equal to this number? So let's start at the top. Equal to, double equal sign. Is 3 equal to 3? True. Yes, the output of that will be true. For our relational operators, when we use our relational operators, the answer will always either be true or false. There are only two outcomes with a relational operator. Whereas opposed to our arithmetic operators, we had lots of numerical outcomes. You could have lots of outcomes. Here we only have two outcomes, true or false, with relational operators. So here are some of our basic relational operators. Assessing if two things are equal to each other. Is 3 equal to 3? Yes, the output is true. Not equal to, if you want to assess if something is not equal to something in Python, the syntax that you use, syntax means the format, like how you format it, how you structure it. The syntax that we use is exclamation point and equal sign together. Spaces do matter here. Do not put a space between your exclamation point and your equal sign. When we're talking about an operator, we're considering it one thing. So spaces do matter in between those two things. So don't put a space there. So is 3 not equal to 2? True. 3 does not equal 2. Sometimes we want to assess if a number is greater than another number or less than another number. Is 3 greater than 2? True. Yes, 3 is greater than 2. Is 2 less than 3? True. Yes. I realize now that all these say true and I should have put some false ones in there. Maybe I should have done a false example. False and true examples. Okay. Notes for myself. Less than 3 is true. And sometimes we want to know if it's greater than or equal to. So is 3 greater than or equal to 3? The answer is true, because while 3 is not greater than 3, it is equal to 3. And the last one is less than or equal to. So is 2 less than or equal to 3? The answer is true. 2 is, in fact, less than 3. So here's some usage examples. The rules are consistent across operators. So just like I said, with the other operators, spaces don't matter in terms, like I said, don't put a space between the equal sign. That will be very confusing. But in terms of on the left and the right side of the operator, the spaces don't matter. So you see up above in the first example here, I have 1 double equals 1. Is 1 equal to 1 is what that is asking, versus 1 equals 1, double equals 1 with no space versus 1 double equals 1 with lots of spaces. They all do the same thing. The spaces are ignored by our Python interpreter. Improper usage of these things will produce an invalid syntax error. So we'll get an invalid syntax if we try to do A double equals BC. Remember, we said it goes operator, it goes object, operator, object. Here we have object, operator, object, object, and the program doesn't really know what to do with C. What are you trying to do with C, that extra object, when you're trying to evaluate is A double equal to BC. It's not sure what to do there. So that is an error that will be produced. I think I have some examples here. I have them in the slides and we have them in the notebook. Let's try to work through a few. So we did the you try it. Now, let's look at this, this code here. The 1 double equals 1. We're going to get true as a response to this. If we change this to something else, let's change it to 2, because we're going to get false. So your outcomes can be true or false. If we change this to 0, double equal means, let me put that up here. Double equal, is our relational operator, is one of our relational operators, and it means equals to. It means is what is on the left side of the double equal sign equal to what is on the right side of the double equal sign?
Why is it a double equal just is a pi?
That's a good question. Why is it a double equal sign as opposed to a single equal sign? It's a great question. So the single equal sign is reserved, a different reserved keyword for our assignment operator. So we're going to talk about assignment operators here in a few slides. And I know this is really small, so I apologize. But the assignment operator is a single equal sign. So that's why we can't use the single equal sign. So it has to be the double equal. Not all languages use the same syntax, by the way. So if you program in Java, it might not be a double equal sign for a quality assessment for a relational operator. So each program sort of has their own way of how they define these things. But now that we're learning what operators are, what assignments are, what variables are, those things broadcast across different languages. And then you can just figure out what is the syntax that represents the relational equality operator in Java, for example. So that's why we're talking about them at these kind of global concepts. Okay, so 1 double equals 1. True. This with a large space in it is true. Again, this will throw us a syntax error. We can fix that by maybe removing the C here. And then we get false because we're assessing, is A in fact equal to B? The answer is false because A is 1 and B is 2. And sorry, leave that here so I'm not changing the notebook. And 1 is in fact not equal to 2. So there's some examples here that you guys can work with and play with. So double equals, does not equal, greater than, less than, greater than or equal to, and less than or equal to. I want you guys to try it here. We have a you try it. Write a Python, it says write a Python program, but write some cells, create some cells that, and for the first one, I want you to compare if 15 is greater than 10. Check if 8 is less than 12. Verify that 20 is not equal to 25. Determine if 30 is equal to 30 and test if 50 is less than 40. Let me spend 5 minutes on that. So 34, 8, 39. Okay.
But you do have it half left. No?
This is what I have, but my daughter has one. I'll say it like tomorrow.
Okay. Let's try to do this exercise. So how do we compare if 15 is greater than 10?
15 right caret 10.
Excellent. Perfect. What about check if 8 is less than or equal to 12?
Less than,
8,
it's, and then it's the left here.
left caret. Then what?
You said to 3,
To 12.
12, and add
12. Excellent. How do we verify that 20 is not equal to 25?
I think it was less than or equal to the previous one.
Oh, the previous one was less than or equal? My bad. There we are. Verify that 20 is not equal to 25.
not equal to the quotation.
20, then what?
Quotation sign said not equal to
Quotation. Exclamation?
exclamation.
Exclamation. No, you're good. And then what?
And it's not equal to, what was the number?
25.
25.
25. Awesome. True. And how do we determine if 30 is equal to 30?
It would be equal, 30, equal, 30.
Perfect. 30 double equal 30. What about 50 is less than 40?
Left,
Left caret.
yes, left here.
You got it. And then 40.
Number 40.
Awesome. Great. We're moving right along. Let's do logical operators, assignment operators, and then I will let you guys take a break, and then we will talk about let's finish operators, this entire operator section, and then we'll take a short break, and then I will do the other content for the next 45 minutes, which are variables. Okay, so we just did this. Logical operators. So we talked about our arithmetic operators, and then we talked about our relational operators. Now we're going to talk about our logical operators. So this controls the logic within our program. And our logical operators combine conditional statements. They evaluate conditional statements. And it always returns a Boolean. So just like our relational operators, greater than, less than, equal, always return a Boolean, our logical operators will return a Boolean as well. The syntax for logical operators in Python are lowercase and, or, and not. So the and logical operator will return true if both statements are true. So is 3 greater than 2? This is a relational operator on the left-hand side. 3 greater than 2, that is true. We just learned that 3 greater than 2 returns true. I need a whiteboard. Okay. Here we go. This is programming, guys. All right, so we just learned that 3 greater than 2, 3 greater than 2, and 2 less than 4. Okay, so we know this returns true, but we're gonna ignore that for a second. So this is our code that we're putting into our program. we know that this is a relational operator. And we just learned that all relational operators return either true or false. And we know that 3 is in fact greater than 2, and that this is going to return true. Now this is true, and this is 2 is less than 4. What is this going to return? True. So now we have a true and a true. So our AND operator, this AND operator here in the middle, will return true if both statements are true. So these in fact are both true, so this is going to return true. Now, what if we had 3 is greater than 2 and 4 is less than 4? This is going to return true. And this is going to return, what is this going to return? 4 is less than 4.
4, it would be false.
It would be false.
Because 4 can't be less than 4.
4 cannot be less than 4. Now we have true and false. What does this return? False. We have a true and a false, so that will return a false. So that's the AND operator. We have the OR operator. So the OR operator returns true if at least one statement is true. So let's look at the same example. 3 is greater than 2, or 4 is less than 4. We said that this returns true, or false. True or false. What is this going to return?
False.
Returns true if at least one of the statements is true.
So it would be true.
So this would be true.
So if, okay, so this is just in my brain, so I'm trying to understand. So if the right logic or the operator is true, then the ending will be true as well, even though it's false. The second logic is, or operative is false.
Because we're using or. Yeah, sorry, I switched that mid-sentence. So these were ands, those were ands, and then we wanted to say, okay, what if we used an or? Yeah, you were right though. If this said true and false, it would be false. Yes, you had the thinking right. But if we're using the or operator, only one of these has to be true. The only way that or returns false is if they're both false. So if we have 2 is greater than 2, or 4 is less than 4, this is false. Then we have false or false. And what's that going to return?
False. Or
False. Yep, you're right. So returns true if at least one of the statements true. If they're both false, it returns false. Just to add a little bit of complexity to this, we have something called the not operator. And the not operator reverses the result. So if we had not 3 is greater than 4, that returns true. So let's look at that. Not 3 is greater than 4. Is 3 greater than 4?
No.
No. So this returns, this part of it returns
false.
True.
false. 3 greater than 4, false. But I think I know where you're going though. Overall, yep, you're right. Sorry. Not false. This is where it returns.
Yeah.
True. Yep. That's what you're trying to say. You're all correct. So this reverses that. So if we said not 3 is greater than 2 or 4 is less than 4, it would reverse this true to a false. So not reverses the result. Okay. Some usage examples. Relational operators return true. Excuse me, shiver. It's cold in here. I forgot the jacket. Next time I'll bring the jacket.
That's why I'm like,
It's
cold. I
freezing
can't
in
sit
here.
there anymore. It's cold.
true and true will return true. False and false will return false. All other scenarios return false with the and operator. I realize these are all and operators. I think I did these on the board, so we don't need to go into this too much. One thing to note at the top there, Python and many other programming languages are case sensitive. That means that, do you see where I said true, and I made and in uppercase A and D? It threw an error. And has to be lowercase. That does matter to the programming language. So it is case sensitive. It's not like SQL. SQL, you can make things uppercase, you can make things lowercase. It doesn't matter. It matters in Python. It makes a difference. So
I also
case
noticed-
sensitive.
Sorry.
Yeah.
When we executed, we didn't have to highlight the block that we wanted to execute. It executes the last operation, even though I have a bunch of operations sequentially. But when I hit Shift Enter, it validated the last one. It didn't give me an error because it's saying like, hey, give me a bunch of stuff. Which one do you want me to do?
You're right.
Is that-
When you point out a good nuance. When you run the cell block, it actually ran all of your operations. It will only print the results for your last one. So it's only printing the results for the last one. It actually ran all of them though.
Oh, I see.
It will run your whole code block. Yeah.
Also, if there was an actual error in one of them,
You would see
it'll
it.
spit out the eye.
Yeah. You can test it out too. You can open that, try to make an error like earlier in that code block. I totally encourage anytime you guys have creative thoughts like this, like just try it out. Just see what it does. That really is the best way to get familiar with the language. Try to do that and see that it produces an error earlier in that block. But yes, it does only print out the results for the last line of code that you wrote. It does do that. I do find that slightly annoying, but you can make it print. If you want it to actually print the results, you can use the print function. Yeah, which we're using in some of these examples, but we haven't talked about it yet, which is why I haven't dove into it much. I want to build some foundation so we have some things to print. Okay, so example usage. We can go into our notebook. Let's try it out a little bit here. So we have 3 greater than 2. We know this is true. We have 2 less than 4. We know this is true. We know that true and true will produce true. So theoretically, this is true. This is true. So we know true and true produces true. So if we combine those two things, 3 is greater than 2 and 2 is less than 4, that should also produce true, and it does. And we saw here that it is case sensitive. So it matters that you use lowercase a and d. If you uppercase it, you'll get an invalid syntax error. False and false produces false. False and true produces true. Again, not just the and statements and the or statements are case sensitive. I also want to emphasize that false is case sensitive, so you cannot do false and false. That's going to throw another error for you. It's the first letter is capitalized. The other ones are lowercase. So the F on false is capitalized. The T on true is capitalized. So that's the syntax for true and false in Python, which are reserved. Okay. So there's examples of logical operators here. A is, if we set A equal to true and B equal to false, we can do A and B, A or B. We can do not A. We can use our X and Y values and use and operators or operators and the not operators to reverse the outcome of that.
Emily?
Yeah.
I noticed that if you just put the equation or you just write like 30 equal 30, it comes out with true, and then if you put print and then 30 equals 30, it also comes out with true. So, so probably like less is probably more. So you shouldn't do print with the just a string or whatever in parentheses. I see that sometimes you're putting print with the.
Oh, yeah.
Sometimes you're not, and so I'm wondering if there, if there's any significance to that.
If there's any significance to using the print statement?
Yes.
There is. So what, sorry, remind me your name here on the front. Remind me. Matt? What Matt was saying is, Matt said, hey, I did a bunch of operations. He said, hey, I did A plus B. Let me just put numbers in
No, I
here.
did that too, but I did that too, and then I have the same thing, that the most recent.
Correct.
Yeah, but is the same thing with print?
It is not the same thing with print. So if we do the print statement, we're actually going to get all of them. So if we wrap these in a print,
So when you put them in parentheses, you're right.
when we put them, I guess wrapping is just a term. If I was gonna use an official programming language terminology, I would say when we pass that to the print function. So we're passing these, the outcome of this to the print function. So you see now I got 4 and 7.
Oh, I see.
So when you see me printing in this block here, the significance is that when you scroll down, you get to see this. And I'm putting some text in there too, because it's a little, just seeing false, true, false doesn't mean anything. So this is me trying to say A and B is false. A or B is true. So trying to make it a little more readable, I guess.
To get the code to generate.
To get the code to generate. She was asking why, so we have this A and B. She was asking, why did you put A and B inside of a print function here, as opposed to just doing it like up, as opposed to doing A plus B like this is, I think, what, remind me your name.
I mean, this last night is what I was asking.
Leslie, yeah.
Celeste.
Celeste, thank you. So Celeste was asking, why did you put these in a print function? And it's because I put just this entire block here of examples. And since they were all in one cell code, if I wanted it to display the results, I have to put those in a print function, because as Matt pointed out, if we just stack all these operations, it's only going to show us the results of the last one. We have to wrap them inside of a print function, or pass them to a print function, proper terms, in order for that, in order for it to display all of the results. Yeah.
The results of the code, correct?
The results of what ran. They run regardless,
Okay.
but for us to see the results, we have to print them to the console.
Okay.
So on that, this screen that you share with all the green, with the, this
Yes.
number, yeah. And then at the bottom when you run it, like, why does it run it like that?
Why does it show A
Yeah.
and B
Yeah.
is false?
Yeah.
I think these are operations of the print function. And the green are comments. And I do have slides that talk about comments, and I do have slides that talk about print functions. So it's a little bit of a chicken or an egg thing. Let's keep talking about operators, because I want to continue to get through the lecture, and I want to continue to get through the content for you guys.
So you're saying like false or true, it says on the thing here. That's because you said print.
It's because I said print and I passed a string, which we haven't talked about strings yet. I passed some text in, and it said A and B.
Is this parentheses?
Yes,
Okay,
these
okay,
parentheses
okay.
define a string.
Gotcha.
Yep, correct. Yep. Okay, let's. All right, our assignment operator. Somebody asked at the beginning of class, why don't you just use the single equal sign for equality, saying is 100 equal to 200? And that's because the single equal sign is a reserved keyword for an assignment operator. probably the most important assignment operator in Python programming and in programming in general, because it's how we're going to store values. So the assignment operator, the single equal sign, assigns a value. So x takes on the value of 5. Anytime we use x in our program now, it's like using the number 5. It's great because now if we can assign a value to a variable, we can use it in multiple places and it can do multiple things. And we don't have to keep using 5. And then we can change it and then we can modify it. So as you guys work with your calculator, you're going to create a variable and it's going to take on the value of something. So you're going to use this assignment operator. This is called the assignment operator. And you're going to use it to hold the value as you're adding or subtracting or applying these different operations inside of your calculator. There are other fancy operators. We don't need to focus too much on these. I'll make you aware of them. There's the plus equal sign, which adds and assigns. So if we have x plus equals 3, that's the same thing as saying x equals x plus 3. If we have the decrement operator, so if we have x negative equals 3, that's the same thing as saying x equals x minus 3. You can do multiply, and you can do the same thing with multiplication. You can do the same thing with division. Basically what this is doing, let me take a picture of this whiteboard and then erase it. Hold on. Okay. I think I left the, okay. Basically what this is doing, let's whiteboard. I'm just going to do the first one. We're not going to go through all of them, but let's go through the plus equal sign because I think it's worth knowing. Just in case you guys see it, you know what it is, what it does. Okay, so the plus equal sign. If we have, so x equals 5. So x takes on, we now have this variable x, which we're going to talk about, and it takes on the value of 5. So if we call x, we would get printed to the screen 5. That would be printed to our console. If we do x plus equals 3, that's the same thing as doing x equals x plus 3. So what this is going to do is it's going to add 3 to the value of x. So x now takes on the value of 8. So if you printed x to the console, it would now return you the value of 8. So that's all the plus equal sign does, is it adds that value and reassigns it back. Whereas opposed to if you just did x plus 3, that would return to the console a value of 8, but it would not update. It would not update your variable. You need the assignment operator to update that variable. Okay.
What's the practical use of that?
What's the?
We reuse the variable basically.
Yeah, reusing the variable. So a practical use of that is if you're looping over something and you want to create a counter, and every time you do something you want to count, you're going to add 1. How many times did you do that action? You've done it 10 times. So a counter is a good practical example. That's a good question. I should add that on there. Thinking about next time I'm going to bring a notebook and I'm going to take notes as we go because that's helpful to think of what to add to these slides as we go. I am going to write that down actually. Okay. Some usage examples here. So the assignment operators can save values for later use in the code. So once we say x is equal to 10, we can use x anywhere in our code and it will recall that value. The assignment operators stores the output of the operations on the right side of the operator. So I just want to emphasize that we can't, it goes, when you say x is equal to 5, has to go, this is your variable, this is your assignment operator, and this is what you are storing. So what you're storing, is on the right side of the equal sign. You can't put it on the left side of the equal sign. Like we wouldn't go 5 equals x. That's not going to work. Your 5 equals x is not going to work. Variable name, assignment operator, what you're storing into that variable is on the right side. It doesn't just have to be one thing. It can be whatever x plus y evaluates to. So we can set x is equal to 10, y is equal to 5. X plus y can be stored into z. So it doesn't just have to be, x equals 10, y equals 5. We can assign these complicated things into these variables. Okay. Let's see, print x is an invalid keyword for argument. Print. Your assignment operators must be executed on an independent line of code. So do you see up here, I'm trying to do print x, and I say x equals 10 in the middle of my print statement? That's not going to work. We need to assign on its own independent line of code. So x equals 10 on its own line, or y equals 10. We can't try to throw x equals 10 or y equals 10 into a print statement. You're going to get an error there, just like I'm showing. Additionally, code, it cannot be executed. So what I'm saying is it cannot be executed as part of an expression, a print statement, or other statements. It's its own statement, the assignment operator is. Also, you can't try to do 2 assignment operators on one line. That's not going to work. You can't do x equals y plus 10, which is equal to 3. One assignment operator per line. Okay, there's a whole bunch of examples in the notebook of assignment operators. Like I said, you can't put the assignment operator in the print, so you'll notice that it's on the line before. And then I'm just printing out the results. So here I'm changing the value of x. So we have an x, we're setting it equal to 10, and the output is 10. And then we're doing, plus equals 5, and that changes it to 15. 15 minus equals, we're doing x minus equals 3. Now x takes on the value of 12. X star equals 2. Now x takes on the value of 24. X divide equals 4, now takes on the value of 6. So I'm doing operations and changing the value using assignment operators of x. So x is updating and changing throughout this code. So the value it holds at the end of this is not the same value that it held at the beginning. We're changing, that's the power of variables, is we can...
Like a cumulative almost.
Yeah, we can manipulate them. We can change them. We can do things with them. That's how our program's going to be able to work, is by enabling us to change them and do things to them according to the logic that we build. All right, I do want you guys to try it. I want you to write a Python program that assigns the value of 50 to variable y, use the plus equals to add 20 to y, use the minus equals to multiply it by 2, divide equals to divide y by 5, and minus equals to subtract 10 from y. Let's spend another 5 minutes on that. Maria, I am telling people that I do recognize it's 9:09. If you want to drop off, feel free to drop off. Definitely feel free to stay as well. But I do recognize it's 9:09. So I'm going to keep going for another 30 minutes, 35 minutes. It is freezing in here. I need more of the barbecue chips. I need more variety. The looks like the Cheetos mix was a favorite today. Okay. How do I get this? All right. We'll just keep going on here. Maybe we should. Yeah, we'll keep going here. Membership and identity operators. Okay. Do you want to review these? Okay, let's do it. Let's do it. I'm glad you said that. I was going to move past it. It's good. This is important. Let's do, this will be interesting, actually, I think, to look at, because this will start to ground our understanding of how programs work. So let's assign the value of 50 to variable y. How do we do that? Y equals 50. Great. Now let's look at that. So we pass just y to our console, and we can see, yep, we can validate y does take on the value of 50. It returns to us 50. As somebody pointed out, we could do it this way as well. We could actually print it. Yep, we can. It does essentially the same thing if there's not multiple lines of code. Now let's use the plus equals operator to add 20 to y. How would we do that?
Y plus equal 20.
Y plus equals 20. Now let's validate that. Now y actually takes on the value of 70 now. So it had the value of 50. And when we said plus equals, it added 20 to that, and then it stored that back into y. Yeah.
Weird is I clicked on that same field again, and ran it again, but we shift enter again, and it incremented another 20 on top of that.
Let's do it.
Kind of ran it.
Let's run it again.
Tripped me up because I hadn't noticed it.
Now it's 90.
Yeah, that's what happened to me. So I was like, now. Then I realized that the more I click it.
Let's click it again.
Because it's added 10?
Now it's 110.
Yes, added.
Every time we run the plus equals operator, it will add 20, save it back into y.
Well, unless you go back and run that other one that says y equal 50 again.
Let's do it.
If you do that, you reset your value back to 50.
Let's do it.
If you run it again.
Y is now 50. And now it's 70 again.
It reverse.
Well, we went back to the top and we reset it.
So when we use the assignment operator, if down here, so we know that y takes on the value of 70 because now I'm going to say y equals 5, and we're going to print y. Now it takes on the value of 5. So you pointed out, remind me your name again. Melanie. Okay. Melanie pointed out a really great point, which is that if we use the assignment operator somewhere else in our code, it's going to overwrite that value. And it's not going to ask us, are you sure you want to overwrite this? It's just going to overwrite it. So we did overwrite that with the value of 5. If we went up here and we ran this cell again, boom, boom, now it's 25. So we did plus equals 20, and now it takes on the value of 25. And I would like to use this point to emphasize that just because the cells go top down doesn't mean they're always run top down. We can run the cells in any order that we want. There's a lot of the implication of running the cells out of order. I think it makes notebooks less reproducible from a production system standpoint. So when you guys get to the API class, I think those are good questions to discuss with Jeremy. So you'll go through Python, and then there's machine learning 1, machine learning 2, and then there's the API class. So when you guys are in the API class, that's where these things start to become relevant. when we're deploying this into production? How do we ensure that everything was run top to bottom, etc.? How do I ensure my code is reproducible and that experiment is valid compared to like other people's code?
So you're basically checking.
Yes, once we get to that point. So that's when running things out of order becomes relevant. The other time it's relevant is sometimes you can get bugs and it's hard to understand where that came from or why it's not working. I think for this class, we can just like clear everything and then rerun everything from top to bottom. So I don't foresee that becoming an issue. Okay, let's do the next part. Well, let me clean some stuff up here. So we did y equals 50, and then we added 20. And let me just delete this here.
Divided by 2, multiply by 2 after the adding 20.
Let me just delete this here. Okay, so now we're going to multiply by 2. So y, what do I do next? Star equals 2. What would happen if we just did star without the equal sign? What if we just did y star 2? Y star 2. So it's 280. But what if we print what the value of y is?
Well, it just multiplied y by 2, but it did not reassign the y value.
That's it.
It did not reassign it.
That's it. We multiplied y by 2. You got
Or
it.
Just added it. Okay, it just
But it-
multiplied the numbers.
But it didn't reassign that 280 back to y. You see y still takes on the value of 140. All right, next part. Let's divide by 5. Y minus equals 5. Divide equals 5, sorry. Let's y. And final one, subtraction. Y minus equal 10. And our final value of y. I got 18. Is that what you guys got?
I got 68, but
I also might have done something wrong because I was kind of playing around throughout this.
140 divided by 2 is 70, 70 minus 2 is 68. So at some point we
Minus 2 or 10?
well, we divided by 2.
Divided by 2 or divided by
Oh,
5?
No, that's fine. I divided by 2. So that's fine.
There you are. All right. Great. Moving right along. All right. A couple other operators to be aware of. Since we're talking about operators, I'll mention these. I think the first 3 sets of operators, the arithmetic operators, the relational operators, and those conditional operators are the ones for you guys to focus on. But I want to mention these as well. There are operators that are membership operators. So there's an operator in Python called in. It's a keyword in Python called in. And it returns true if a value is in a sequence. And it's quite useful. So we can say, is A in apple? A in apple. And it will return true because A is in fact a letter that does exist within the string apple. We can say there's another operator called not in, which does exactly what you would assume it would do. It returns true if the value is not in the sequence. So if we say Z, not in apple, we would get a value of true. Let's look at these two and then we'll talk about identity operators. Let's look at the membership operators. Let's see, assignment operators, sorry. Okay, membership operators. Let's I want to add a few more. I want to do the Apple stuff here. Okay, I'm realizing I need a keyboard over here. So if we said A in Apple, and notice our keywords in Python when you're working in this notebook, they highlight and show up as blue, which is kind of nice. So just like Word editor will highlight things for you if they're misspelled or your syntax is wrong. This will do that as well. Also notice it put a little yellow line under Apple. That's because Apple, that's because I have a typo here because I didn't put it as a string. Okay. Oh, you are right. Good catch there. Do you know what it's called? There's this thing called pair programming, which is where when you're programming, you're like meeting with somebody else and they're also like helping you find issues like you did. So thanks for pair programming that with me. That was really helpful. A in Apple. And that returns true. Let's see if Z is in Apple. Z in Apple. Z is in fact not in Apple. We got false. Yeah. You got it. Of course. Yeah.
I think you had a little smaller before.
Okay. So
just to finish it up.
did you get what you needed?
No, ma'am, hold on a second.
Here.
Try that.
How's that?
On my phone. That's much better. Thank you.
There we go. Perfect. Of course. So if Z in Apple, A in Apple, let's try A not in Apple. False. Z not in Apple. So you guys already learned what the not app operator does. This is just another way that you can apply the not operator. So we already learned about the not operator. We can apply it onto in as well. So it reverses the outcome of that. So A is not in Apple is of course false because A is in Apple. But if we say Z not in Apple, that returns true because Z is not in the word Apple. This is why Python's so readable, by the way. Z not in Apple. Like that is just so easy to read. That's so easy to parse and understand. And that's one of the many things that are beneficial about this, what people like about Python language. Okay, identity operators. So is returns true if variables are the same object. So X is Y. X is not Y returns false if variables are not the same object. So let's try that out. Let's try is. Let me see if I have that down here. Here we go. We have X, 1, 2, 3. We have Y equals a list of 1, 2, 3. Z is equal to X. We can print X is Z, and that in fact is true. We can print X is Y, and that in fact is false. So Z is equal to X. So Z points to X, and X points to 1, 2, 3. So these three things are the same, even though X and Y are both two lists that look like 1, 2, 3. They are in fact different objects. And I don't want to get into this identity operators too much. I shouldn't even have it on here, honestly, because we haven't talked about variables yet. So we're gonna skip. So I do have examples in here for you guys, though. we can, I'm going to skip this. I don't think that makes sense at this point in the slides. We can do this one though. Let's create, let's not create a list. That's just going to really confuse us at this point. Okay, this is fine. Let's do objects. It's 9:37. I don't know if I want to start objects. Let me give you guys a precursor for where we're going to go here. Okay. The next thing that we're going to learn about is we're going to start to learn about objects. I'm going to give you guys a precursor for what we'll talk about next time. We're going a little slower at the pace of this class. That's okay. It's more important that you guys actually understand these concepts and that they're grounding with you and that you can use them. So we can adjust as we need to. I'm not worried about it. I don't want to try to squeeze in objects in like 10 minutes. I think that's not going to work. So, or be fair to you guys. But I want to give you guys a precursor. So we'll go through like an introduction to objects so it can sit with you guys. It can resonate with you guys over the weekend. And then we'll dive into this more on Monday's class because you guys are asking such good questions. And I think you'll ask really good questions on these objects on Monday as well. So let's talk about this. Great. We understand operators. And this whole time I've been telling you, it goes object, operator, object. Well, what is an object? So we talked about operators. What is an object? Well, in Python, things that we represent, like the numbers we're working with, the integers, those are objects. The strings, we've already started to look at strings. So we just had the word apple, right? We just had the word apple. That's a string. We're going to learn about that. That's an object. Lists, if we're putting numbers into a list, we had 1, 2, 3 that we quickly looked at. That's a list. That's an object. Everything in Python is an object. And objects, they store data and have associated behaviors and methods with them. And so there are certain things that we can do with objects. If we define something as an integer, if we put these things into boxes and classifications, then we can say, well, you can add integers together. You can subtract integers. If we define something as a string, like apple, we can say, well, you can't add strings together. That doesn't make sense. Or maybe if you do add strings together, it would just be like apple and banana, and we squish them together in something called concatenation. So there is value. What I'm saying is there is value in defining things as objects, defining what things are, because then we can decide how the program can or can't interact with those things. So everything is an object in Python. And objects store data. This is data. Apple is data. 1, 2, 3 is data. The number 8 is data. Objects store data, and they have associated behaviors with them. A variable, you've also heard me say variable. Let's store things into the variable X. Let's, create a variable, a new variable. Let's assign that to the variable. A variable is a name used to refer to an object in memory. So here we have X, assignment operator 5. X, the variable X, is used to refer to the value of 5 in memory. It's going to store 5 in memory somewhere, and then every time we call X, it's going to go. The computer program is going to go back and look where it stored that value. We updated it to 8, so that's why it says 8 right now. Variables are dynamically typed in Python. So notice when we said X equals 5, we didn't say X is an integer, and I'm going to set it to the variable 5. Dynamically typed means that Python, as a programming language, it says, I think this is the object that this variable is. You don't have to tell me it's an integer. You don't have to tell me that it's a string. You don't have to tell me that it's a list. I'm going to look at what you passed to me, and I'm going to assume the object type that it's going to take on. one of the biggest advantages of Python, that it's dynamically typed, that it infers the type associated with these variables. Not all languages do that. So Java is a very verbose language. In Java, I don't remember the exact syntax, but you have to say like X is an integer and it takes on the value of 5. So you have to define like the type of your variable. In Python, we just say, hey, X is 5 or X is, list of 1, 2, 3, or we say X is equal to apple. And under the hood, Python's saying, oh, this is an integer, this is a list, this is a string. It's determining that. It's smart. It's figuring that out itself. We talk more about that in these slides, by the way. So in Python, an object is something that represents a very specific piece of data or functionality. So I'm creating a differentiation for you guys here between variables and objects. They are different things. So a list is an object. We can assign our own creative name that we've decided to call something to that object. We've decided to call it numbers, or we've decided to call it numbers2, or we've decided to call it name. Whatever makes sense for your program. So a variable is a name that you are choosing, that you are creating, and it is referencing some stored object in Python. Again, we'll go through these again. So every object in Python has 3 key components. It has an identity, it has a type, and it has a value. So every object, so this is a integer. This variable type is an integer, and it has a value of 5. This variable type is a list, and it has a value of 1. This variable type is a string, and it has a value of apple. They also have identities associated with the object, because I could have string x equals apple, x equals apple, x equals apple, and the program needs a way to tell the difference between those. So there's the identity piece as well. It's a unique ID. The more important thing I want you guys to focus on are, let me see how many slides I have here. Okay, we're going to stop 2 slides. Here's where I want to get. Python's core data types. There are, this is where I want you to focus on. We have numeric types. So we've already started to talk about integers. What is an integer? What is an int? It's a whole number. So 10, 15, -5, 2,743, 8,000,007. Those are all integers. It's a numeric type integer. Python's other core data type for a numerical type is a float. Floats are anything with decimals. 3.14, -2.5, -1.73, -0.00000004 numerical types. Okay, we have integers and floats, floating point numbers. We've already talked about true and false, and you guys saw in the code that highlights blue, so it's clearly a keyword in Python. And that is something called a Boolean, or a bool. And that is the Boolean type in Python is bool, and it's represented as either true or false. Sorry, that bullet point should have been indented in the second one, often used in comparison for logical conditions. The other core data type in Python is something called a string, or str, and this represents textual data. You can sometimes see it as a double quote or a single quote, such as the word hello here. So double quote hello, single quote world. Those are strings. I have 3 more objects to throw at you. So these are the most basic ones. We started to work with some of these already. We have already worked with integers. We're starting to work with floats. We already started to work with bools, and we already started to kind of like play with strings a little bit. So we have some intuition of what these things are. throughout the rest of these slides, when we meet on Monday, we're going to go in depth in all of these things. Integers, floats, bools, strings. And then we're eventually going to build to these Python collection types. So integers are useful, bools are useful, strings are useful, but sometimes we need to group things together. We need to create a list of things so we can iterate over them. I need to create a list of students so I can iterate over them and create an enrollment schedule. Like if we want to create sophisticated programs, we have to start grouping things together. And that's where these data structures come into play. So a list is just an ordered mutable collection. We'll talk about what all that means when we get into the depth of these slides. So we can say fruits equals open square brackets, apple, banana, cherry. And then we print fruits, and we have apple, banana, cherry. And tuple is a different type of collection. It's a different type of Python collection where we can still store pairs. It's an ordered immutable collection. That's how I'll say it. So here we have coordinates equals, and in its syntax is to use the parentheses here. So 10, 20. And then this last one is called the dictionary, my personal favorite. I don't know, either that or list, but dictionaries are pretty cool. No, dictionary is my favorite. It's an unordered collection of key value pairs. So we have student, I don't know if you can even see that, Alice, student, the key is name, the value is Alice, the key is age, the value is 20. So it's a key value pair. We'll talk about what these are, what they mean. We have a whole set of slides on these. This is where I'll leave you guys, but I'll give you confidence that that we will, in fact, go through each and every one of these in depth. So we'll talk about key features of an integer, how to cast them, int versus integer. We'll do uTry-its. So we'll go very much into depth. As you guys can see, there's quite a few slides here on all of these.
Will you go back to the Python collection types?
Yes, happy to. All right, I'm going to end the stream, and then I'm going to see what questions you guys have.